Hello everyone, this is atomic structure tutorial question 2. Okay, I wouldn't do much explanations. I will zoom into those parts that I think you probably have problems with. Okay, filling up this table, I don't think is an issue. I will touch on two things. One is the electronic configuration for chromium and chromium 2 plus and iron 3 plus. Okay, these two. Okay, now before we look at the electronic configuration, I just want to draw your attention to two things required here. First is the full electronic configuration, and the second is the ground state. Okay, what is this full electronic configuration? Okay, full electronic configuration means that I need to write, okay, starting from 1s2, 2s2, 2p6, and so on. So this is full. Okay, in contrast to something that's not full, okay, it means a short form. Okay, I can use a noble gas configuration, okay, to represent. Okay, for example, let's say I want 1s2, 2s2, and 2p4. Okay, so instead of writing the full, I can use 1s2 is the electronic configuration of helium. So helium 2s2, 2p4. So I can write in such a way. Okay. Of course, for other periods, I will use different noble gas. Okay, helium, krypton, neon, argon, and so on. All right. Okay, so I have addressed these two, full and okay, I haven't talked about ground states. Okay, ground states, I would say that most of the electronic configuration that we write are ground states. Okay, in contrast to excited states, okay, which can be any configuration actually. So I can fill 1s2, 2s2, 2p3, and instead of 2p4, I can have 2p3 and then 3s1, which means that the valence electrons are excited, are raised to a higher energy level. Okay, that one will be very random. Okay, so we will always use the term ground state, okay, to qualify, okay, what we are talking about. All right, we first talk about iron 3 plus first. Perhaps that is an easier example to talk about. Okay, iron 3 plus. Okay, I'm not sure how many of you actually did it in this way. Okay, iron has 26 electrons. Okay, I minus 3, it becomes 23 electrons. Okay, some students may feel it this way. They may feel the electron from 1s2, 1s2, 2s2, 2p6, 3s2, 3p6. So this is already 18 electrons, right? And to reach 23, I need 5 more, right? And you know that we fill 4s first, right? So some students may feel it like that. 4s2, 3d3. Do you write your electronic configuration in such a way with 23 electrons? Okay, if you have done that, then the answer is wrong. Okay, wrong. Why? Okay, we remember that we fill 4s first. Okay, but because it's a cation, means electrons are removed from the neutral atom. So which means that we need to remove the 4s first. And I shouldn't be seeing my 4s electrons in the electronic configuration. Okay, so this is not the correct way of writing. So instead of writing 3d3 4s2, my electronic configuration should be from the electronic configuration of my neutral atom. I remove my 4s and then I remove another 3d. So it's 3d5. Okay. All right, over here, I shouldn't be using short form because since the question asks for full electronic configuration. So I should be writing 1s2, 2s2, 2p6, 3s2, 3p6, and 3d5. Okay. All right, similarly for chromium, for cations, okay, I would say that for cations or transition elements, it's better to write the electronic configuration for the neutral atom first. Then I remove the number of electrons accordingly. So for chromium, this is a anomaly. Okay, remember 4s1 3d5. This is an anomaly because of the stability of the half-filled 3D orbitals. Okay, then I remove 2 electrons because it's chromium 2 plus. Okay, I remove the 4s, I remove one of the 3D, so become 3D4. So this is the electronic configuration for chromium 2 plus. Okay, so this is writing of electronic configuration. Okay, especially for cations, take note of that. I write for neutral first, then I remove from 4s first, then 3D. Okay. All right. I think for the anion, it should not be an issue. Okay, drawing of orbitals. This question wants you to draw all orbitals. Okay, so N3 minus have the 1s, 2s, 2px, py, pz orbitals all occupied. Okay, so I'm writing them one by one. So I'm drawing them one by one. Okay, so px, py, and pz. Okay, then question 2b2. Okay, this one is a past year A-level question. Okay, they want you to compare 1s and 2s orbital and also a 2s, 2p orbital. Okay, I don't think it's too difficult. It's just that it's not a normal, usual way of asking. Okay, similarity between 1s and 2s is that same shape. The difference is that one is bigger than the other. One has more energy than the other. Okay, 2s, 2p, similarity, same quantum shell. Okay, the difference is that they have different shapes. They have different energy level, and one is directional, one is not. Okay, because the spherical one does not have a direction. All right. Then next one. Okay, suggest why nitrogen forms anion. Okay, but not a cation. Okay. Remember, taking in electrons to form anion or giving out electron to form cation, both requires energy. Okay, so now it's a balance of which one is more energetically favorable. Okay, to lose 5 electrons, okay, to lose 5 electrons requires more energy, right? 5, no, larger amount of energy remove 5 electrons compared to gaining 3 electrons. Okay, gaining 3 electrons also require energy to hold on to the 3 additional electrons. So removing 5 electrons is more, requires more energy. All right, so therefore it's more favorable to form anion, N3 minus. Okay, now this part, they want you to sketch and label the 3D orbitals in iron 3 plus. Okay, iron 3 plus, that's how we wrote, is a 3D5 electronic configuration. 3D5 means that I have all 5D orbitals filled. 1, 2, 3, 4, 5. All filled, so I got to draw all. Okay, I'm going to draw all of them here. Okay, I just want to make mention because some of you may be confused, okay, concerning the dxy and the x square, y square. Okay, the difference between these two orbitals, okay, is that, okay, the xy, yz, and xz, these three, okay, the butterfly loops are in between axes. Okay, if I were to draw, okay, I will draw them in between axes. Okay, if this is the y-axis and this is the x-axis, I will call it the dxy. Okay, if I were to change this to a z-axis, then I will call this the dxz, dyz. Okay, now comparing to the x square minus y square. Okay, the loops are on the axis. Okay, you see how I draw on the axis, whereas this one is in between axes. Okay, on the axis. So the dx square minus y square, this is your x-axis, this is your y-axis. Okay, so that's the difference between the first 3 sets and this fourth one. All right, the last one I think is quite obvious. A dumbbell and then a ring in the middle. All right.